Hello everyone. In this video, I'm going to present about independent and mutually exclusive events. Intent of the presentation. The presentation deals about probability and its importance in real life, independent events, mutually exclusive events, comparison of both with examples. Finally, the summary of the presentation. What is probability? Probability is a mathematical term for the likelihood that something will occur. That is, the chance that something will happen. It is the ability to understand and estimate the likelihood of any different combination of outcomes. The probability that an event will occur is mathematically given as probability of event E is equal to number of favorable events divided by total number of outcomes. Here are some real-time examples for probability. Card games, sports statistics, natural disasters, winning the lottery, buying insurance, predicting the weather, and so on. These are the some familiar examples about probability. Tossing a coin, rolling a dice, playing cards. Events. When we say event, we mean one or more outcomes. For example, getting a tail when tossing a coin is an example for single outcome. Also, rolling an even number in a dice is an example for more outcomes. These are the basic types of events: impossible and sure events, simple and compound events, independent events, dependent events, mutually exclusive events, exhaustive events, and complementary events. In this video, we are going to see about independent and mutually exclusive events in detail. First, independent events. Independent events are those events whose occurrence is not dependent on any other event. These are the events where the outcome of the first event has no impact on the outcome of the second event. That is, the first event has no influence over the other event. Examples of independent events are flipping coin. You can flip a coin and get a head, and you flip a second coin and get a tail. So the outcome of head in first flip and outcome of second coins as tail is independent of each other. Rolling dice. You can get 4 in first roll and 5 in second roll. Both are independent of each other. Next, mutually exclusive events. Mutually exclusive events are events that cannot occur simultaneously. In other words, if one event has already occurred, another event cannot occur. Mutually exclusive events are disjoint and dependent, but not all dependent events are mutually exclusive. Examples of mutually exclusive events are tossing a coin. We cannot get both a head and a tail at the same time. Also, for rolling dice, we cannot get both 4 and 5 at the same time. We can either get it or tail. Similarly, we can get either 4 or 5 at the same time, but not the both. This implies that the occurrence of head results in the non-occurrence of tail, or the occurrence of tail results in the non-occurrence of head. Comparison between independent events and mutually exclusive events. Independent events. They do not control the occurrence of other event. Occurrence of one event has no influence on the occurrence of other event. But in case of mutually exclusive events, they cannot happen simultaneously. Occurrence of one event results in the non-occurrence of the other. For independent event, probability of A and B is equal to probability of A into probability of B. The conditional probability of any independent event is simply the probability of the same event. probability of A divides B is equal to probability of A. For mutually exclusive events, probability of A and B is equal to 0. Also, the conditional probability is 0, which implies probability of A divides B for mutually exclusive event is 0. Here are some real-time examples for independent and mutually exclusive events. For independent events, winning a card game and running out of milk, buying a lottery and finding a penny on the floor, that is, your odds of finding a penny doesn't depend on you buying a lottery. For mutually exclusive events, the examples are sleep while eating at the same time, running forward and backward at the same time, turning left and turning right at the same time. All these examples cannot be happened at the same time. So these are categorized under mutually exclusive events. Here, for independent events, let us consider this example. It rains, I win the lottery. There is no relation between these two events, but these two events can take place at the same time. So, independent events has no relation between them but can take place at the same time. So, the Venn diagram of independent events overlap. Whereas, for mutually exclusive events, let us consider the example, I flip head, so I cannot flip tail. That is, the occurrence of head results in the non-occurrence of tail. Either head or tail, but not head and tail at the same time. Mutually exclusive events cannot take place at the same time. So their Venn diagram do not overlap, which is similar to the disjoint sets. Summary of the presentation. Independent events do not have any influence over the occurrence of other events. Mutually exclusive events do not occur simultaneously. Mutually exclusive events are dependent events. For probability of A or B is equal to probability of A plus probability of B plus probability of A into probability of B in case of independent events. In case of mutually exclusive events, probability of A or B is equal to the probability of A plus probability of B. Thank you.